what is the cosmic microwave background? By the way, guys, if you want to support the channel and do a super chat, you should feel free. Most welcome. I really appreciate it. The CMB is often called the baby picture of the universe. It represents the moment about 380,000 years after the Big Bang. So literally when the universe was around 380,000 years old. So the universe is more like 14 billion years old now. When it was around 380,000 years old, which is very young, that is when these photons are from. So after the Big Bang, when the hot primordial plasma cooled enough for electrons and protons to combine into neutral hydrogen, because remember, we've talked about how during the Big Bang, things were constantly colliding. Photons, electrons, positrons, they were constantly colliding. They were in this hot, dense plasma, and we couldn't really form neutral hydrogen at that time. Now, remember, quiz question, the most abundant element of the universe is hydrogen, and it is the only element, as well as a little bit of helium and very trace amounts of lithium, that the Big Bang actually made. So basically, all of that is to say that this hydrogen, during the time of the Big Bang, was not even in its neutral form, but at this point, at 380,000 years old or so, it's now starting to cool enough to become neutral hydrogen. Okay, so about 380,000 years after the Big Bang, when the hot primordial plasma, so this is literally the Big Bang primordial plasma, cooled enough for electrons and protons to combine into neutral hydrogen, an event known as recombination. So this is what we call recombination. Before this, the universe was opaque. Photons, or light particles, constantly scattered off free electrons in the plasma. They would constantly interact. Photons and electrons would constantly interact. So all of this scattering off of each other was happening, unable to travel far. So constantly photons and electrons would be colliding. Actually, photons, electrons, and positrons would be colliding with each other in this hot mess, and would not be able to really travel far. At recombination, the scattering stopped and photons were released to stream freely through space, turning the universe transparent. The light from that moment has been stretching, redshifting as the universe expands, and today we observe it as a CMB, a nearly uniform glow at a temperature of about 2.7 kelvins. So it's just above absolute zero. It's not quite absolute zero. It's still there, and we can measure it. Importantly, the CMB is not perfectly uniform. Even though it looks very smooth, its non-uniformness or non-homogeneity is very difficult to pick up on. You need a very sensitive instrument, but it is there. It has tiny hotter and colder patches, only tenths of microkelvins. So only tenths of microkelvins, different from the average. So literally the fluctuations of the CMB are tenths of microkelvins away from the average temperature of the CMB, which is 2.7 kelvins.